Hello everyone, this is the second video of lecture 5. I want to write the TCP model in Gusek in a different way. I solved this TCP model in Gusek in my previous video. It was this. If you remember, I wrote everything in our Gusek software like whatever you had on paper. For example, 0.3 multiplied by x1 plus 0.4 multiplied by x2 greater than or equal to 2, and the other constraints and objective function. But what if you have hundreds or even thousands of variables and constraints? It's impossible or very difficult to write down everything here. Now I'm going to show you how to write this model in a different way, parametrically model the problem in Gusek and try to solve it again. So let's do it. When you see this model, you see that you have two variables, three constraints. The number of variables is for set j. J can be 1, j can be 2 variables. So you have two decision variables. You have three constraints. For each constraint, you have index I. So set I equals to 1, 2, and 3. Constraint 1, constraint 2, constraint 3. Since you have two decision variables, you have two coefficients in the objective function. C1 is 20, C2 is 15. C1x1 plus C2x2. So the parameters of coefficients in the objective functions is vector C, C1 and C2. So your problem will be Cjxj summation over j. This is the objective function. For each constraint, similarly, you have an equation. Aij xj less than or equal to bi. Aij is the coefficient of variable j in constraint I. For example, A11 is 0.3, A12 is 0.4, A12 constraint 1, variable 2, A21 is 0.4, A22 is 0.2, and so on. Right hand sides are B1, B2, and B3. These are the lower bound and upper bounds of decision variables. 0 and 0 are lower bounds of variables, and 9, 6 are upper bounds of decision variables. So let's start to write the model. First, you need to define your sets. How many sets do you have in this problem? We have a set of indices for variables, set j, and a set of indices for constraints, set I, as you see in this parametric model. Set j can be from 1 to 2, and set I from 1 to 3, 1, 2, and 3, 3 constraints. So let's define the sets here. Set j, capital J, semicolon. For decision variables, set capital I for constraints. Whenever you want to have a comment for any line of your Gusek code, you can start with slash, then star, write your comments. Set of decision variables. Again, star and a slash. Similarly, for this one, I want to write a comment. This is set of constraints. We defined our sets. Now it's time to define your parameters. The first parameter here you see is Cj, the coefficients of variables in the objective function. So let's define them. Parameter It's not a variable, it's a parameter. We know the value of these parameters. C, the index of C is J. You need to have that index in curved brackets. Capital J, Cj is our parameter. What is it? It's objective coefficient. So I'm going to write down the name of it, objective coefficient. Don't forget about the semicolon at the end of Cj, at the end of the line, before your comment. Parameter, for example, A, the coefficients of decision variables in constraints. What are they? I and j. It has two indices. As you see here, aij. Again, semicolon, then the comments. These are constraints coefficients. What else? What do I have in the model? The right hand side of the constraints, again, it's a parameter. It's b and its index is I. It's from set I, 1, 2, and 3. Semicolon, and it's right hand side. Don't worry about the values of these parameters yet. We are gonna get there soon. What else do you have? Lower bounds and upper bounds are of decision variables. Lower bound of x1 is 0, upper bound of x1 is 9. So let's define them here again for these parameters too. L, what is the index of lower bound? It's j, because it's for decision variables. It's lower bound of variables. And upper bound, u, so it's just a name, L and U for lower bound and upper bound respectively. uj, upper bound of variables. We define all of our sets and parameters. Now it's time to define our variables. How many variables do we have? 2 variables. Previously, we defined variables x1 and x2 separately. Sorry. Now here, I want to define them in one line. So, we have variables x in curved bracket, j in set j. Small j is the entities of a set. So for a small j in the set j, they are greater than lj. This is bracket, not curved bracket. When you use small j or small I, entities of a set, you need to use bracket, comma, less than or equal to uj, semicolon. What does it mean? It means that you claim that you have a variable x. How many x do you have? It depends on set j, the index of in set j. J can be 1, j can be 2. I'm going to define them later. Each of them are greater than or equal to parameter lj, less than or equal to parameter uj. Pay attention that these are brackets, but here we have curved brackets. You want to minimize your objective function, colon, objective function name, colon, summation. Do you remember how we had it previously? It was 20 multiplied by x1 plus 15 multiplied by x2. I wrote down everything, but now I want to write it like this. Summation over j, cj, xj. So let's do it. its summation over what? It's over j. So j in set j. What do you have in front of that summation? Cj multiplied by xj. So you just need to write it this way. C small j inside brackets multiplied by xj semicolon. That's it. So it's gonna read parameters c and parameters x, variable x multiplied to variable x, and it goes from for all entities in set j. J is 1, j is 2. I'm going to define it later. Instead of this line, I have summation over j, cj multiplied by xj. Subject to a series of constraints. So we need to have a name for our constraints. For example, const c, whatever it is, it's just a name. How many constraints do you have in this problem? 3 constraints. So you want to name them constraint 1, constraint 2, constraint 3. So you have an index here too. What is the index for constraints? It's I in set I. So the first one is when I equals to 1 is constraint 1, colon. What do you have in constraints? It's again, for each of them is a summation of aij multiplied by xj less than or equal to bi. Let's write down this one. Summation is over j. J in j. Summation is over j. What do you have in front of summation? A, I and j. See, when I use the entities inside a set, small I, small j, I use bracket, not curve bracket. Multiplied by xj should be greater than or equal to bi. Semicolon. Previously we defined 3 lines. Now with just 1 line we define all of the constraints. Solve. Can I write end here? No, because I forgot something. What about the data? It's not complete. This is my model. I want to solve the model, but what is C? What is the values of A? What are the values of B? And so on. So here you have another section data. So when you define your model, you have solve command, then at the end you need to define your data. First we define set. So let's say what is my set? Set J, capital J, equals to, when you want to assign something for parameters or sets, you need to have a colon and then equation, equal sign, 1 space 2 semicolon. It means that entities of set J are 1 and 2. Set I, if you remember, we had 3 constraints, 1 space 2 space 3 semicolon. We also have parameter C equals to one. You need to define, since C has index J, you need to you determine what index has this value. If J equals to 1, its value is 20, as you see here. C1 is 20, C2 is 15. So 1 is 20, enter, next row, 2 is 15, semicolon. We also have parameter A. Parameter A has two indices, I and J. So we don't have just a vector 1, 2, 3, and 20, 15, and so on. It's a table. So when you write A as a name of the parameter you want to define values for that, after colon, then you need to have the second index here. Second index is J, which is 1 and 2. When you hit tab key on your keyboard, you can have this distance. It's okay if you want to just put space, enter space. 1, 2, then colon equation sign. What are your first index? It's I. I can be 1. I can be 2. I can be 3. So here in this table I have I's and J's. When you write something here, it's the value of A1, 1. When you write something here, it's the value of A1, 2, A2, 1, A2, 2, A3, 1, A3, 2. What is A1, 1? In the model, A1, 1 is 0.3. So just write it down, 0.3. You don't need 0.3. 0.3 is enough. A12 is 0.4. Next line. A21 is 0.4. A22 is 0.2. A31 is 0.2. And A32 is 0.3. At the end, semicolon, and that's it. You enter matrix A, the coefficients of variables in the constraints here. You also have right hand side parameter bi. So you say parameter b equals to, the index is I equals to 1, 2, and 3. So for 1, it is 2, the right hand side of the first constraint. When I is 2, it is 1.5. When I is 3, it is 0.5. Semicolon at the end. You also have parameter L. You defined Lj here. Similarly, for j equals to 1, because it was Lj, for j equals to 1, it is 0. For j equals to 2, it is 0, 2. Parameter u. Oh my God. U is, again, the index for u is j. When j is 1, it is 9. When j is 2, it is 6. Okay, we are done with entering the parameter values and end at the end. So this part of the model is data section. The program will use this data section in this model and then solve it. So you go to tools. Oh, I need to save it first. Save it as tcp2.mod. Again, don't forget about mod. I go to tools, generate output file on Go, and then run the model. optimal LP solution found. So let's see the result. Yes, it's 92.5. Same solution, 2 and 3.5. Same solution as our original TCP problem, this one. So you could write the model like this.